Hey everyone, in this video I want to talk about Azure AD certificate-based authentication. The ability to now authenticate using a certificate stored on a smart card, some USB key, and not having to use a password as we traditionally think about. As always, a like and subscribe is appreciated. Now if we take a step back, if I think about authentication, there are different options we have to authenticate. We can think about, well, there's something I know. This could be the idea of a password, a PIN. It could be something I have. This could be, sure, a token, a smart card. It could be my phone with the Authenticator app. It could be my laptop with a TPM using something like Windows Hello for Business. And it could be something I am, a biometric, a fingerprint, a 3D map of my face. And if I use two or more of these factors of authentication, something I know, something I have, something I am, we think of it as a multi-factor authentication. So a stronger authentication as more things are involved. And what we're seeing today is there's a move away from passwords. And there are a number of initiatives and government-mandated authentication schemes that actually want to use an X.509-based certificate. The idea that we have asymmetric keys. Now remember, the whole point of the asymmetric keys is I have a private key. And that private key can perform some cryptographic operation that can only be reversed using the public key. So everyone can have the public key, only I have the private key. So if I can do some cryptographic operation that is reversed and can be confirmed using the public key, and I trust the public key by whoever signed that, and thereby trusting, well, they did due diligence in giving me the private key, well, then I can use that as part of my authentication. And there are a number of standards around, hey, smart cards, around these kind of USB devices that I can store that private key on and use it as part of the authentication. And the whole point is, hey, if I can perform that cryptographic operation with the private key, it proves I have the private key, I am who I say I am. Now, to be able to do this whole X.509 certificate based, if you think about it, it means I need some public key infrastructure in place that can issue those keys, that can assert, yes, they are who they say they are, that has the capability to revoke certificates if there's some compromise. So I have these certificate authorities. So I can think, okay, I have some PKI deployment. And the chances are you may have this already. You might be using Active Directory certificate authorities. There are a number of different ways I can do this. Now, this is not new. The idea of using certificate-based authentication has been around for a long time. But previously, to do this with Azure AD, I would have to use Federation. I could use ADFS, and ADFS supported that certificate-based authentication, which could then be used by Azure AD. But I had to have that ADFS or something else as part of that authentication flow. And what we're talking about here is, hey, I can just do it natively with Azure AD. So I need something to issue those certificates to the smart card, to the key, whatever that may be. And if I already have a PKI infrastructure, chances are I can use that. There's a few things to consider. Hey, I need to make sure I have that certificate revocation list available. So hey, if I do have some compromise, if I do need to revoke it, that's available through the web so people can go and check. Hey, someone's trying to use the certificate, have you revoked it? If it's not on the list, okay, great, I'm good to go. And when I issue the certificates, I want them to have a certain lifetime. And the people issuing the certificates, well, their certificate has to be good for a certain duration of time so they don't run out before the certificates they're issuing runs out. So when I have my PKI deployment, I have a root certificate authority, which has its own certificate. The root is normally really, really long-lived. In a very typical environment, we'd actually maybe take the root offline. It's not actually used to sign directly. Instead, we have these intermediary certificate authorities which have their own signing certificates that were signed by the root CA. So we start to get this chain of trust. And then the intermediary CAs, well, they would sign the issuing certificate of these issuing CAs. And the whole point is, if I trust the root, well then it's basically vouching for the intermediaries that are vouching for the issuing, so we're good to go. So we have this chain of trust. Now the whole point is, at this point, what are we actually doing with this chain of certificates? So I want to be able to generate a private key and its corresponding public certificate, the public key, so I can use it for authentication. Now, I want to make sure that private key is in one place. I don't really want it to be available here, and in a PFX file that could then be read into all these different places. Ideally, I want it in one place. The whole point of this is this validation is proving I'm in possession of the private key. That private key is in one and only one way to do this. Now, there are different ways to onboard when I think about this, because fundamentally what's going to happen is I can think about, let's change color for a second. I'll take this color. We're going to have some smart card. We're going to have some USB device that the user is going to be in possession of. And what I want to happen is one of these issuing CAs is basically going to go and generate and give the private key stored on this. It could be a USB device, it could be a smart card, whatever this is, this entity, this thing that I'm holding, that only I have. Also, it's obviously generating the public certificate that has the public key that corresponds to that private key. So it's generating and giving out both of those things. Now I need both of these. Remember, it is signing this public certificate. So it's vouching, hey, this really is who it's saying is. And the whole point is this level of assurance is by the fact that private key is in one place and one place only. Now, there are different ways to onboard the user, because the whole point is, hey, some user is going to have this device. Now, for example, I have a PKI already in my Active Directory environment. I can use that. One of the options is I can set up auto-enroll. I create a new certificate template. So if I jump over for a second and we go and have a look, what I did is I took an existing template and I duplicated the smart card template. So there is a built-in kind of smart card template available, and I duplicated that to, for me, create this new YubiKey template. Now I set it for a validity of 1 year. I wanted it to published in Active Directory, and I had some settings about the automatic re-enrollment. Now the key part of this is in the cryptography section. I want the key storage provider, and then I said the provider is the Microsoft Smart Card Key Storage Provider. And then I published this in Active Directory and I set it up for auto-enrollment. Now the key point of doing that, and the reason we have this option here, is what I then want to happen as part of this all-up solution is if it's auto-enroll, the user will see a little dialog box in the corner of their screen. Say, hey, go and enroll for this certificate. When they click it, because I've selected that particular Microsoft Smart Card Key Storage Provider, it won't try and just save it locally to the machine. It's going to make them insert that USB device, that smart card, and then it will enroll directly onto that device. There's no intermediary PFX file that could end up going to other places. Now, if I take that approach though, obviously now I'm writing to that smart card, writing to that USB device. The built-in driver for things like, hey, the Yubico device is read-only. So it would not be able to actually go and do that enrollment. So what I would have to do is have the full read-write driver distributed out to all of the machines in my environment where it's doing that auto-enrollment. I could use group policy for that, MDM for that, but realize I have to have that full read-write driver locally on the machines if users are doing auto-enroll. I actually also need that full read-write driver if I'm doing remote RDP using that smart card authentication. I could push auto-enroll via a script. I could have maybe special machines. So rather than the user enrolling on their machine, maybe on each floor of my building, I have an enrollment kiosk. That has the read-write driver. So when someone joins my company, hey, here's your starter kit, here's your key, go over to the kiosk and do your enrollment. Administrators could enroll on the user's behalf, then as soon as the user gets it, they change the PIN. So there are many different things that I can do. But what I want to make sure is that key, that private key, only exists in one place. I really want that security of the key only being directly involved onto the USB, the smart card. I don't want it floating around in a PFX file because I'm losing some of that assurance. So I've got this. I've done this. I've made sure, okay, the users, they get their keys, they get the certificate. I'm enrolling it using some method. Now I need to use it with my Azure Active Directory. Okay. So I have my specific Azure AD tenant. So I've got my Azure AD. Well, by default, it doesn't trust this PKI. So what I have to be able to do is the things that are issuing the certificate and the root. So I'm going to take whatever levels I have, all of these different things. I'm going to upload these. I create the SIR file. I export out the public key parts of these. I upload them and basically now saying Azure AD, I want you to trust these signing authorities. So if you see certificates from users that we can go and look up the trust chain, if it's signed by these, you're good. We trust these PKI environments. They're doing the right checks before they issue those user certificates for the smart cards. We're going to allow authentication with those. And I can just go, if I go and jump over here, in my environment, for example, I exported out my files, and all I really have to do is then use the Azure AD commandlets to import them in. And if I run my command here, you can see I've done that. Now, my PKI environment is super, super simple. So all I have is my root CA. I don't have a whole set of intermediaries or issuing, but you can see I have imported in, and it was of a type root authority because I just have one layer, a particular signing authority that I can now use, and Azure AD is going to trust as part of the all-up configuration. So step one, I get the SIR files and I import them into Azure Active Directory. So then step two is its configuration in Azure AD to say, hey, yes, I want to support certificate-based authentication. It might be for a subset of the users. There's some configuration about, well, is this single factor or do I want to consider it multi-factor authentication? Because remember, got the key. So it's saying I have. So that's one factor, yeah? But to use it, I have to unlock it. This could be with a PIN, something I know, or it could be some of them are biometric. I put my thumbprint on it, something I am. So it's saying I have and either know or am. So it is two factors. So I can pick, do I consider this a single factor authentication or a multi-factor authentication? And then the certificate, well, how am I binding the properties in the certificate to the user principal name that's the actual Azure AD account? So I have to go through and configure those things to actually be able to use this. So if we jump over to my Azure Active Directory, So remember, I've uploaded the CERF files already. Then I can go to my security. I can go to my authentication methods. And I can go to certificate-based authentication. I've already uploaded the cert. I've already enabled it. And I'm enabling it for all users. Then in the configuration, well, I've configured it to actually be considered multi-factor authentication. So it's going to meet things like conditional access MFA requirements. I can set special rules for different types of configurations I might need. And then I've done binding from the certificate values of principal name and RFC 822 name into what is the user attribute, in my case, user principal name. So that's how I'm binding and matching those. But again, I could add special rules based on elements of the certificate issuer, based on the policy OID, in how I want to treat that. So I can do special things. But once I've done this, I'm essentially ready now to do certificate-based authentication for the users I have enabled this for. And again, in my environment, well, I've enabled it for everyone. So then how can I use this? So today, the Azure AD certificate-based authentication is all about authenticating to Azure AD using that X.509 for web-based applications into Microsoft Office client applications that use modern authentication. It is not log on to the machine today. I think this is going to expand, but today think of it as, hey, web browser-based applications, Microsoft Office client apps using modern auth. Macintosh, web-based log-on Office as well, but whereas Windows can use multiple certs on the keys, Mac will only use the first key. So that's just something to consider. So what's going to happen then is I, as the user, there's some cloud application that supports modern auth. So I'm going to go and talk to this. And as usual, it says, well, hey, I need a token from Azure AD. I trust Azure AD for my authentication. So as part of that authentication, so I talk to Azure AD, there's now going to be an option in the logon that I can say, hey, I want to use a certificate. I'm going to click that option instead of typing in a password. At this point, there is a separate certificate authentication endpoint. So I go and talk to that. It confirms. It goes and checks things like, hey, the CRL to see if the certificate I'm using has been revoked. It does checks. And then ultimately, once this passes, hey, this will create my primary refresh token as always and give it to me that I can then use to go and get access tokens for particular services. Now, as part of this certificate-based check, I select the certificate I want to use. And to use the certificate on this device, well, at that point, I have to unlock it. So that's where it does this PIN or this biometric-based check. So that's the flow of what we're actually going to do. And I want to show that. So what we'll do is let's jump over to our browser. Now, before I actually go kind of full screen on this, let's create a guest session. And what I want to do is go to the myapps.microsoft.com. Now, also what I'm going to kind of bring up in the corner is I have this little application. This is for the Yubico device. So right now, my key is sitting in the packet. So I'm going to take it out of the packet. And it's my little USB. I'm going to connect it in. So I've now connected that in, and now you can see it's kind of flashed up as, oh, you've put in your key. So it's proving, hey, I'm using that device. So what I'll show, before I do anything else, if I just focus on that device for a second, if I go and look at Applications PIV and look at certificates, we can see, sure enough, I've got the cert issued by my CA on this device. So I'm definitely using this USB key as part of this authentication. That's really the key part I wanted to show as part of this. So now I'm going to go and sign in as usual. I'll use my name. I'll type that in. Sign in with a certificate. I'm selecting this option. I pick the certificate, so I'll select this cert. If I look at the certificate information, well, I can see that issued by information. And I can also go and look at things like the subject alternate name, and then I can see that principal name. I can see that RFC 822 name, which we configured as matching to the UPN as part of that Azure AD configuration. So I'm going to use that cert. At this point, to use that cert, remember, hey, something I know or something I am, I have to enter the PIN. So now it can use the cert. And there I am authenticated in. And that's the process. Now, if I jump out of this and actually go and look at the sign-ins that we have, but this one here where the user is the user ID, this is talking to that certificate-based endpoint. This interrupted, well, that's when it's asking me, hey, do you want to remember this? If we look at this one, this is interesting. It's showing me the authentication requirement is only single-factor authentication. But if I go and look at the actual additional details, we can see the actual authentication level was MFA because I configured, remember, the MFA to be, yes, certificate-based authentication. I am considering MFA not a single factor. We can see the root key type. Hey, it doesn't know what that is. But we can see all of those details were used as part of the authentication. And if I actually went and looked at the auth itself, we can see the details around, hey, that Azure AD authentication request that uses that certificate. So that was the flow. We can see from there that complete set of actions that was using the certificate. See, I've still got my key in there. But what we're doing really is, hey, we have some PKI infrastructure that is being used to enroll the keys to the user's smart cards, to their USB devices, whatever that might be. I'm telling my Azure AD to trust this particular PKI instance. I'm then configuring to say, yes, I want to use certificate-based authentication for my Azure AD and configure it to particular groups of users or everyone. Do I want to treat this as single factor or multi-factor? Mappings of the certificate attributes to, hey, is it the UPN or an on-prem? And then when I authenticate as the user, hey, I want to use certificate-based authentication. It goes and talks to a cert endpoint. I select the cert I want to use, the one on my card. I have to unlock it with a PIN or biometric. And then the authentication continues as it normally would. And that's it. I mean, that's really the key point of everything we're doing at this. It's just a new way, not a new way, it's been around for a long time, a new way native to Azure AD to perform that authentication. And again, there's lots of different solutions. So I did use kind of this Yubico key. And I do want to kind of say a thank you to Yubico. They spent an hour with me on the phone talking through some of the best practices around this thing. They even sent me the keys. It's not sponsored by them, but I appreciate their time. But there's lots of solutions out there. There's different types of device. There's different options I can leverage. There are, of course, other ways that I can do authentication. There's FIDO2, which adds the requirement of a local gesture as part of the authentication. And I can actually do that on this as well. Maybe I'll do that in a future video. But this is the point. If I have those requirements to do certificate-based authentication, I can now do it directly with Azure AD without requiring an ADFS in the middle of it. Today, it's focused around those web-based applications, those Office apps that use modern authentication, but I expect that to grow in the future. So I hope that was useful. As always, till next video, take care.